Hi there, welcome to an emergency review on paper 1, linear and quadratic functions. You just finished taking a test. Let's call it a formative assessment on this unit, and we need to review some skills. Let's take a look. In this presentation you will see not only the full solutions to all the test problems, but also then a problem of each type to try again on your own. So let's take a look. So from the math test, from the first paper, paper 1, let's take a look at this problem. This was question 1. It says line 1 passes through a point and is perpendicular to a line, and line 2 is the inverse of a line that passes through these 2 points. Find the intersection of line 1 and line 2. Okay, well our job first is to, if we're going to find the intersection of two lines, we first have to have an equation for each line. So let's concentrate on each line one at a time. Line 1 is perpendicular to this line, it says. Okay, so we know when two lines are perpendicular, the slopes have a important relationship. So let's take this line and solve for y. I moved the 2x over to get this. Now I know the slope of this line is -2. This is the slope value. So that is not line 1. That is the line that line 1 is perpendicular to. So now that we know that slope, we know line 1 will have this slope. We know the relationship between slopes is you take the reciprocal and make it negative. So -2 over 1 turns into 1 over 2. That's our slope of line 1, and we also know line 1 passes through this point. So we know slope and a point. When we know a slope and a point, we can use this form. Y minus this equals half x minus this value here. That will give us the equation of the line. Simplifying that, this part, we get this, half x, and this is +2, half makes a 1, and then moving the 5 over, we get this. So there's the equation of line 1. Now let's figure out line 2. Line 2 passes through these 2 points. When we know 2 points, we can find the slope first and then use this same form here to find the equation. So let's find slope. But it told us, however, that those are not the 2 points for line 2. These are the 2 points that the inverse of line 2 passes through. And we know when two lines or two equations are inverses that we swap the x and y values. So notice how I took these 2 points and I rewrote them like this. See how the y value became the x value and the x value became the y value. And same thing here. This x value became the y value and this y value became the x value. Now we have the points on our line because line 2 was an inverse of that. So now we can take these 2 points and find the slope. So 11 minus 1, y2 minus y1, over x2 minus x1. That gives us a slope of 2. So line 2 has a slope of 2, and then we can use point slope form to find the equation. So here's the slope, here's y minus, I'm using this point, y minus 11 equals the slope x minus 4, and now I have the equation of line 2 like this. So finally, we have line 1 and line 2, we have the equations. An alternative way to do this one would have been to find the equation of this line and then find the inverse of it, and that would be then that would give you then the slope of the line you need. Alright, so let's check. So here's our two equations. We can set them equal to each other. That's what finding the intersection means. So we're finding the intersection by setting them equal. I'm going to multiply everything by 2 to get rid of this half. Alright, now I'm going to move this x over here and this 6 over here, and that tells me x is 2. Once you know x is 2, you can put it into either equation, so let's say in here, and get y, so y is 7. So we know the point of intersection of those lines is 2, 7. Let's take a look at a graph of that. Here is the intersection. Here is the line that line 1 was perpendicular to. You can see they're perpendicular. So here's line 1, here's line 2 in red, and here's the intersection. Okay, try one. Okay, now that you've tried that one, let's take a look at the work. We have this, line 1 then, is the line 1 again is the inverse. So here's the line you're given, and the inverse then, to see how I took the x and y and I just swapped them here. Now I'm going to solve for y. Y has been solved for to give us line 1. Line 1 has this equation, k is unknown. Line 1 is perpendicular to a line that passes through these 2 points. So perpendicular line to line 1, you take the 2 points, you find the slope, and then the slope of the perpendicular one using those 2 points is this. Therefore the slope of line 1 must be this, because we took that reciprocal and made it negative. So now we know line 1, this slope is equal to this here. So negative k over 2 equals that. Solve, and we have k equals 5.5. And I can cross multiply that to solve like that. That gives us k. And then it says line 2 is parallel to line 1 and passes through this point. So line 2 then is parallel to line 1, so it has the same slope. See how it's the same slope? And then it passes through this point, and now we know k is 5.5, so 5.5 goes in here and that. Take a close look at your work there. Okay, from the test, question 2. Question 2 had this. This is a simple one. We have a parabola. We're given two x-intercepts here. It says -2 and 3. Therefore, we can take those 2 points and write intercept form like this. Alright, I put in the 3 here and the 2 here. Make sure you use the opposite signs. -2 is a 2, 3, +3 is a -3. Okay, now to find the a value, we need another point. So I took this point. That point is -6, 0. So I substituted in 0 for x, -6 for y. Solve for a. And solving, this is -3, -3 and 2, and a is 1. Now we know the equation must be this. So actually there was a 1 in front there, and it actually gave a hint of that. In the beginning it didn't have an a in front here, so it's kind of already telling you that probably it'll be 1. So maybe I did this unnecessarily. But anyway, there's my equation, and then change it to standard form like this, multiply it out, and the question was asking what is p and q in standard form, so -1 and -6. Okay, try this one. Okay, let's check our work. So there's one parabola that we're given. Factored form is like this. When you factor that, you get this. Therefore, the second parabola must have the same x-intercept, so it looks the same as this. But the second parabola has some different a value we don't know. We know the second parabola passes through this point. Therefore, we put that point 27, 7 in here. Sorry, 7, 27. 7 for the x, 27 for the y. Solve that, and you get a value of -3. Therefore, the second parabola must have this equation. Again, same form as parabola 1, but the -3 is our a value that we found here. Alright, from the test, question 3. We had a parabola like this, and we had to give it in this form. This is standard form, this is vertex form. To make that change, we need to use completing the square. So I took that 31, moved it over here. I factored out from here, I also factored out a 4. Then b over 2 squared. So 6 over 2 squared is 9. We're adding 9 in here, but here we have a 4, so 4 times 9, 36. We're adding 36 on this side. Go a little bit further, and we have this form here. This is our vertex form. We found that form. State the vertex. Well, the vertex must be -3, -5. Okay, let's take a look at the next question. It says find the x-intercepts. So I have vertex form, and it says this form. This is the form we get from quadratic formula or from solving by completing a square and then solving. So I'm going to make that equal to 0 first, and then I move the 5 over. So this became 0, and then I move the 5. Now I'm going to continue solving. Divide by 4. Now take the square root on both sides. I have the root of that. Now there's this 3 here. I move the 3 over there, and I have this. This doesn't quite look like this, though. If you look at this, I can take the square root of 4, so I can rewrite that as root of 5 over 2. And then I wanted to combine the two fractions, so imagine you had root of 5 over 2. This one, I doubled it, so I could put the two together like that. Okay, check your work with fractions there. You could have also used quadratic formula on this and gotten to the same place. Okay, let's look at part D. Here we have our vertex form, and we're going to transform it. To transform it, we first are reflecting over the y-axis. When we reflect over the y-axis, we're making all x values negative. Therefore, -x goes into here. So we get this. That x is replaced by -x. Next, we're going to do a translation horizontally 3 units right, vertically down 2 units. So horizontally 3 units right means we're putting x minus 3 in. And then down 2 units means -2 from the whole function, because we're doing that. That's affecting y values. So x minus 3 replaces that x. Notice that negative from here is still there. And then -2 goes at the end beyond the whole function, because that's affecting y values. So that's the trick to that one. This turns into this. We have negative x plus 3 again, 6. Common error would be to eliminate those 3's, but they don't because that negative is still there. All right, try this one. And now check your work on this one. There's completing the square. Check carefully that you've done it right. There's the vertex. And then find the x-intercepts by solving that. Set it equals 0. Keep solving, and you get that. Okay, now let's do a transformation on that. So first you're going to, we'll try it out. So it went. So first we're doing there's the function. We're doing the translation first. There's x plus 5, n plus 7. This is left 5, up 7. So apply that. X plus 5 replaces this x, plus 7 goes at the end of the entire function. Simplify all this to get this. Notice these become 2, and this becomes 11. Next, we're doing a reflection over the x-axis and a vertical stretch. So here is reflection over x-axis and vertical stretch here affecting the y value. So in front of the whole function. So now the negative 3 multiplies the entire function, which becomes this. Check your work carefully. Alright, from the test. Number 4. This one was tricky. We had to turn this function into this one. First thing you should notice, it's definitely reflected. Alright, so that's negative x squared. Then I need to compress it because it's going to be compressed eventually. So to check the compression, I did this. I said when I went up 5 units, this went over about, let's see, 2.5 units and 2.5 units this way. So when I went up 5 units, this also had a width of 5 units. But this one here, when I look at this one here, so again, that's 5 units. This one looks like it has, when I count those units, it has a width of 2.5 units. So that was a 5 unit difference. And again, this is 5 units here, 5 units here, and then 5 units here, but here 2.5. So it became compressed, a half of its width. Therefore, to be half of its width, I have to do 2x. Because remember, when it's half its width, I actually do 2 times here with dx. All right, next, we need to now take this compressed one and move it. And it moves over 4 units and up 5 units. So to get it to be where the blue one is, we did 4 units positive on the x, so we put negative here, and up 5. So there's our final form here. All right, kind of tricky. Now that we have that equation, we can change it to standard form. That simplifies like this. Multiply it out. Apply the negative. Add the 5. We get this. So I think in the end it said, what are your A, B, C values? Well, A, B, C. You have to have it in standard form to see those. Try one like this. Okay, let's check our work. We first have to look at the blue one. We're going to flip it. Again, make it negative. And then I look at that distance there. Up 1 unit, this one has a over 1 unit. This one goes down 1 unit over 3 units. So it got 3 times wider. So this time we put 1/3 there because it got 3 times wider. 1/3. And then it needed to move. So again, I've already done the reflection. I've widened it. Now I need to move it. It needs to move like this and like that. So that's plus 5 for the x because it goes minus 5, and then down 4, and it's down 4 here. So there's our equation. Alright, from the math test, last one. This one, number 5. This equation has to have no real roots. That means the discriminant will be equal to, or be a negative. Let's match this up. Here's a standard form. That's your a value. This, all of this is in front of the x. All of that is your b value. And here is our c value. That's the first thing to notice in this one. So no real roots means the discriminant is negative, so less than 0. So b squared is this whole thing squared minus 4 times a times c. That gives you this, then this, and now we have a quadratic like this. Check the work carefully. There's a quadratic. That quadratic must be less than 0. When I divide by negative 3, I get this. But when you divide by negative, the sign changes direction like this. That's important. Alright, now we have a quadratic that must be greater than 0. So we're thinking, when I factor it, I get 2 answers, negative 3 and 1. But I need a quadratic that's greater than 0. And that quadratic is positive, so it sits like this, greater than 0 here and here. Therefore, our answers are this and this, because that's where this parabola is above the y-axis, when it's greater than 0. Alright, try one like this. And now check your work on this one. This one needs two distinct real roots, means greater than 0, and then there's our final solutions. Check it very carefully. I know you can do this.